Okay guys, so today we are talking about a quantization of angular momentum, and this was actually given by Niels Bohr, and what he did was that he calculated the total energy of an orbiting electron. So we start with that part. So let's try to calculate the total energy of an orbiting electron. So the total energy ET is equal to, you have half mv squared, half mv squared added to, by the way, half mv squared is the kinetic energy, added to the electrical potential energy, which is like minus k e squared over r. Now this electron is acted upon by an electrical force, so we'll try to equate that. So we will have k e squared over r squared is technically equal to mv squared over r is equal to mv squared over r. So we will get the total energy. So from here we would get k squared over r is actually mv squared. Now what we are going to do is we are going to rearrange a bit. So the total energy becomes ET becomes equal to half ke squared over r minus k squared over r, which technically becomes ET is equal to minus half ke squared over r. Now at this particular point, Niels Bohr, he made an assumption, and he stated that the angular momentum is an integral multiple of h over 4 pi. So technically his assumption is mvr, that's the angular momentum, is equal to nh divided by 2 pi. Now if we accept this, then what we have is we have m squared v squared r squared is equal to n squared h squared over 4 pi squared. So we will have mv squared is equal to n squared h squared divided by 4 pi squared m and r squared. But earlier we found that mv squared is equal to ke squared over r. What we're going to do now, we are going to substitute that. So we will have ke squared over r, we'll have ke squared over r is actually equal to n squared h squared is equal to n squared h squared over 4 pi squared m r squared. Now from here we could actually calculate r, and this gives you r is equal to h squared over 4 pi squared m ke squared multiplied by n squared. We'll again double check. So we have r is h squared over 4 pi squared ke squared m multiplied by n squared. Now if we try to sub in the values, we'll realize that we get r is equal to R is equal to, so first we have h square, which is 6.6 times 10 raised to the power negative 34, and that squared divided by, this is going to be a long expression, so I'll write here 4 pi squared multiplied by the dielectric constant, which is 8.89 times 10 raised to the power 9 multiplied by the mass of the electron squared, so this is 1.6 times 10 raised to the power negative 19 squared multiplied by 9 times 10 raised to the power negative 31, so 9.1 rather, 9.1 times 10 raised to the power negative 31, which is the mass of the electron, and this is further multiplied by n squared, because we found r as a function of n squared. So from here we are going to get r is actually equal to 0.5 times 10 raised to the power negative 10 n square meters. Now what we are going to do is in the value of r in the equation of total energy. So we had total energy Et as minus Et we had is equal to negative half k E squared over r, and when we sub in the value you get this as negative. So I'm going to sub in the value for r, which was like h square n square 4 pi square k E square m. So let's try to sub in that. So you will ultimately get this is going to be half k E squared, and if I sub in the value for r here, so r is h square n square, and on the top you will have 4 pi squared k E squared m. Now you could rearrange this, and when we rearrange this we get something like this is negative twice pi squared m e raised to the power 4 k squared divided by h squared multiplied by 1 over n squared. And what we do is that we try to sub in the values. So technically we try to get E is equal to, we try to write it in terms of a constant multiplied by 1 over n square. So if we take that constant as c, so that becomes negative c over n square, and we try to sub in the values for c. So technically we are getting c as equal to 2 pi square, then the mass of the electron, which is 9.1 times 10 raised to the power negative 31 multiplied by, you will have the charge on the electron, which is 1.6 times 10 raised to the power negative 19 squared multiplied by the dielectric constant squared. Dielectric constant square is 8.9 times 10 raised to the power 9 squared multiplied by n squared divided by you will have h square, which is 6.626 times 10 raised to the power negative 34 squared, and when you solve this you get the value for c as 2.170 times 10 raised to the power negative 18. And let's try to sub in the value. So you will have C is equal to 13.6 electron volts. We convert it into electron volts, so we can get the expression for energy as negative 13.6 divided by n square eV. So this was the derivation of quantization of angular momentum given by Niels Bohr, and it's a pretty important derivation and for IB exams this is a very important derivation, so you guys should be knowing.